Okay, problem number 3B on the exam. Remember 3 was a choice to either find a series for the log or for this one, e to the minus x squared. Find a series in the interval of convergence for this and use to find a series for this definite integral. Okay, so the way that it works is that the key is that e to the u is equal to this for all u, doesn't matter what it is. Then we want to find a series for e to the minus x squared, integrate it, find the interval of convergence, and then evaluate this. So u is going to be minus x squared. So what we're going to do is e to the minus x squared is equal to this. Over k factorial. We want to clean that up. This is minus 1 to the k, x to the 2k, over k factorial. You need to take this minus 1 out, because notice if you keep it in, when you integrate this, you're going to have minus 2x plus 1, which means that we're going to have every term being negative. But with this, it alternates. So it's really important to take this out of here. Take that minus sign out. So here we go. Now we need to integrate. Integral the sum of minus 1 to the k, x to the 2k, k factorial dx. Well, I integrate. The minus 1 to the k doesn't change. I get x to the 2k plus 1. K factorial times the new exponent. And then I get the plus c. So, now, this is going to be, here's what happens here. If I plug in, no, we're gonna leave that for a second. Okay, so we can leave that in there. That's fine to leave it in there. So what we're going to do next is I need to find the interval of convergence for this. So I'm going to use the ratio. Now I really don't need to, because since this works for all u, that means this series converges for all x. That means this series converges for all x. But I'll go through this. This is going to be the limit rho, limit k goes to infinity. This, absolute that, k plus 1, so that's going to be absolute x, 2k plus 1 over k plus 1 factorial times 2k plus 1 plus 1, all over absolute x to the 2k plus 1 over k factorial 2k plus 1. Invert and multiply. That's going to be 2k plus 3. 2k plus 2 plus 1 is 3. Over k plus 1 factorial 2k plus 2 plus 1. That's 2k plus 3. Now I just invert and multiply. So I'm going to get a k factorial 2k plus 1 all over x to the 2k plus 1. Okay, so I'm going to continue. This is lim k goes to infinity, absolute x, 2k plus 3, absolute x, 2k plus 1, then k factorial over k plus 1 factorial, and then 2k plus 1 over 2k plus 3. Now notice here, this is going to just be, this is a constant, so what we're going to get is that these, you subtract minus 2k plus 1, that's going to be just 3 minus 1, so I'm just going to be left with a square, so I get a constant squared. This is going to be 1 over k plus 1, and this is going to be 2k plus 1, 2k plus 3. Now notice, higher power on the bottom, so this is going to go to infinity faster, but we'll use L'Hopital. In this I'm going to get 2k squared plus 3k plus 2k is 5k plus 3. And that's going to be, if you do L'Hopital once, you'll see this is infinity over infinity. So I get x times 2 over 4k plus 5. K goes to infinity. This is 0. So it converges. That means rho is equal to 0 for all x. So the series converges for all x. This series right here. I'm sorry, this series right here converges for all x. Okay, so the last thing we have to do is we have to look at this. So the integral of 0 to 1 e to the minus x squared dx is equal to this. Well, that's my function, so I'm going to plug in 1 and 0. Well, when I plug in 1, plus c, I'm going to get a 1 here, and that's going to be over k factorial 2k plus 1 plus c. Now this is all going to be minus when I plug in 0. Sorry, that's 2k, 1 to the 2k plus 1, which is 1. 0 to the 2k plus 1 over k factorial 2k plus 1 plus c. Those cancel. This is equal to 0. So what I'm left with is this. So that integral is equal to this. Okay? Now again, that's a hard problem. Not many people got it, and so it's one reason the scale was somewhat forgiving. Okay, I hope that's helpful.